Hello everyone, I'm Gayatri K. My teammate name is Monica AD. This is our BTech final year project, SignBridge, a real-time sign language communication assistant for deaf and speech impaired users using artificial intelligence. This project is designed to bridge the communication gap between deaf users and hearing users through sign recognition, speech processing, and real-time messaging. One major challenge in society is communication between deaf or speech impaired individuals and hearing users. Many hearing users do not understand sign language and interpreters may not always be available. So, we developed an AI based communication assistant that enables smooth real time interaction. The objective of SignBridge is to provide two-way communication. A deaf user can perform sign language gestures in front of a webcam, which are recognized and converted into text. A hearing user can communicate using speech or typed text, and both users interact through a shared live chat interface. We used Python and Flask for backend development. Flask Socket I/O enables real-time communication. OpenCV handles video processing. MediaPipe holistic extracts and an upper body landmarks. TensorFlow and Keras were used for deep learning model training. JavaScript manages front-end interaction and Web Speech API handles browser-based speech recognition. We created a custom gesture dataset by recording multiple users performing sign gestures in front of a webcam. Videos were collected in different backgrounds, lighting conditions, and slight angle variations to improve model robustness and generalization. Using MediaPipe Holistic, the system extracts left-hand landmarks, right-hand landmarks, and upper body pose points like shoulders, elbow, and wrist. Together, this produces a total of 144 numerical features per frame. After extraction, the landmark data undergoes pre-processing. Missing landmarks are handled using zero padding. Coordinates are normalized to reduce positional variations. Fixed length frame sequences are then created for model training. Our final architecture is a CNN plus bi-LSTM hybrid deep learning model. The CNN layer learns spatial relationship between landmarks, while the bidirectional LSTM captures temporal motion patterns from sign sequences. Softmax produces the final class prediction. The model was trained using normalized landmark sequences. Performance was evaluated using accuracy curves, loss curves, and confusion matrix analysis to measure classification performance. Let's run this project by giving python app.py. It will give you the localhost URL, copy and paste it in the browser. You can use Chrome or Edge. Open in two tabs. One is for the hearing user and another one is for deaf users. In the hearing side, we can send the manual text and also we can record it. Now let's record. The speech is converted into a text and we can send that text to our live chat. And I'm sending the text as nice to meet you. This is deaf side. Here also we can send the manual text. We can perform sign language by clicking the start camera. When the system determines that the sign gesture has been completed, we can click the stop camera. The model takes 30 frames as input and predicts the sign with a confidence score. Now I'm signing for thank you and the landmarks are visible on my hand. The confidence score is also visible. It's 100% and I'm stop the camera and send the predicted text to the live chat. Both users communicate through a shared live chat room powered by Flash Socket IO. This ensures instant bidirectional communication between deaf and hearing users. To conclude, SignBridge demonstrates how artificial intelligence, computer vision, and real-time web communication can be integrated to create a useful assistive communication system. Our project focuses on improving accessibility for deaf and speech-impaired users by enabling bidirectional communication between sign users and hearing users. By combining sign recognition, speech-to-text conversion, and live chat, this system provides a simple and efficient communication bridge. In future, this project can be extended with larger gesture vocabularies, sentence-level recognition, multilingual support, mobile deployment, and faster real-time inference. So to summarize our project, SignBridge is a real-time sign language communication assistant developed to reduce the communication gap between deaf and hearing users. This system uses MediaPipe-based landmark extraction along with the deep learning for real-time sign detection. Hand and upper body landmarks are captured from live webcam input and passed through a trained model for prediction. For hearing users, speech is converted into text using the Web Speech API, which allows smooth voice-based interaction without needing additional hardware. A live shared chat module is implemented using Flash Socket IO, enabling instant communication between both users in real time. The complete system was built using Python, Flash, JavaScript, OpenCV, MediaPipe, and deep learning techniques. The major advantage of this solution is that it is affordable, accessible, user-friendly, and designed to provide practical communication support in real-world scenarios. For implementation, the complete project workflow is available in our GitHub repository. The system follows 4 main stages. First, raw gesture videos are processed and MediaPipe landmarks are extracted from hand and upper body movements. Next, the extracted landmarks are pre-processed and converted into numerical sequences for training. Then, the CNN plus BiLSTM deep learning model is trained using these normalized temporal landmark sequences. Finally, the trained model is integrated into a Flash-based web application for real-time sign prediction and live communication. To use the application, the Flash server is started and the system opens in a browser. One tab acts as the deaf user interface for webcam-based sign communication, while another tab acts as the hearing user interface for speech or text interaction. The complete source code, implementation details, and the project workflow are available in our GitHub repository. Thank you for listening to our presentation.